Welcome to this video on series and parallel circuits. This guide is designed for GCSE Physics revision, helping you master the key rules, facts, and exam tips to confidently understand these fundamental electrical circuits. What defines a circuit? A circuit must be a complete, unbroken loop for current to flow. If that loop is broken by a gap or a faulty component, the flow stops entirely. This is the foundation for all circuit analysis. There are two main ways to connect components. In a series circuit, they are arranged in a single loop. In a parallel circuit, components are connected on separate branches, allowing current to split and recombine. In a series circuit, components are joined end-to-end. There is only one path for electrons, meaning they must pass through every component in the loop. While this makes them simple to analyze, they have significant limitations. A key rule for series circuits is that current remains the same at every point. Because there is only one path, the same amount of charge passes through each component per second. Remember this, it is a common exam topic. While current stays constant in a series circuit, potential difference or voltage is shared. The total voltage provided by the supply is divided among the components. More resistant components will receive a greater share of that potential difference. Resistance in a series circuit simply adds up. As you add more resistors, the total resistance increases, which in turn reduces the total current flowing through the circuit. This is why bulbs may appear dimmer as more are added. The major weakness of a series circuit is that one break stops everything. If any single component fails or is removed, the entire loop is broken, and nothing works. This makes series wiring impractical for most everyday needs. To summarize series circuits, they feature a single loop, constant current throughout, shared voltage across components, and total resistance that equals the sum of individual resistances. Parallel circuits use separate branches. Current from the source reaches a junction and splits, flowing through each branch before recombining. This is the standard arrangement for almost all real-world electrical systems. In a parallel circuit, current splits at each junction. The amount of current each branch receives depends on its resistance, with lower resistance branches carrying more current. Ultimately, the total current from the source equals the sum of the branch currents. For potential difference in parallel circuits, the voltage remains the same across every branch. Every component connects directly to the supply, receiving the full voltage. This is why all household appliances work at the same mains voltage. Adding branches in parallel actually decreases total resistance, as it provides more paths for current to flow. The total resistance will always be less than the smallest individual branch resistance, resulting in a larger total current from the source. The strength of parallel circuits lies in their independent operation. If one branch is switched off or broken, the others remain completely unaffected. This reliability is why we use parallel wiring in our homes. Ultimately, domestic wiring relies on parallel circuits to ensure every device receives the correct voltage, functions independently, and remains isolated from faults in other parts of the home. This completes our guide on circuit types. Let's summarize parallel circuits. Unlike series, they offer multiple branches for current. Voltage remains constant across every branch, while total current is the sum of currents in each individual path. Importantly, adding branches actually reduces total resistance. Here is a comparison of series and parallel circuits. In series, current is uniform, but in parallel, it splits. While series circuits share voltage, parallel circuits maintain the full supply voltage across each branch. Notice how these differences affect component failure and their practical use. Cells connected in series act together to provide a greater total voltage. By connecting the positive terminal of one to the negative of the next, their potential differences add up. This is essential for devices requiring more power than a single cell can offer. The formula for total voltage in series is simply the sum of the individual cell voltages. If you connect cells in opposite directions, however, their voltages will subtract. Always check the polarity of each cell when calculating the total potential difference. Here is the #1 exam tip for circuits. Current is the same in series, and voltage is the same in parallel. Remembering these two simple rules will help you solve a massive variety of exam questions. Ohm's law, V equals IR, is your best tool for circuit calculations. You can use the formula triangle to find voltage, current, or resistance. In series, use the common current. In parallel, use the common voltage to find your missing values. Let's walk through a series circuit calculation. With a 12 volts battery and 2 resistors, first add them to find the total resistance. Then, use that to calculate the circuit current. Finally, find the voltage across each resistor using Ohm's law. For a parallel circuit, remember that the branch voltage equals the supply voltage. Calculate the current in each branch individually using Ohm's law. Once you have those, simply add them together to determine the total current drawn from the supply. To succeed in exams, you must know your circuit symbols. From cells and batteries to resistors, bulbs, and meters, being able to recognize and draw these accurately is essential for analyzing any given circuit diagram. Remember how to use your meters correctly. Ammeters must be connected in series and have very low resistance to avoid affecting the circuit. Voltmeters must be in parallel and have high resistance to ensure they draw negligible current. Avoid these common exam pitfalls. Current is never used up. It is conserved. Adding parallel branches decreases total resistance, not increases it. And parallel cells provide the same voltage as one, not a larger total. When conducting a practical investigation, start by drawing your circuit diagram. Build your circuit carefully, take systematic measurements, and then evaluate your results by identifying potential errors and comparing your data against theoretical predictions. Let's try some quickfire questions. If current is 0.5 A in a series circuit, what is it through the second bulb? It's 0.5 A. If a 9 volts battery powers 3 identical resistors, what is the voltage across each? It's 3 V. Continuing our practice. A 12-volt supply with 4 and 8 ohm resistors in series gives a current of 1 A. In parallel, if one bulb blows, the others remain on. And appliances are wired in parallel so they all get full voltage. Finally, tackle our higher-level challenges. For parallel resistors, calculate branch currents separately, then sum them. For series, find the total resistance first, then the current, to calculate the individual potential difference across your component. Let's review the answers to our challenges. For the first challenge, calculating branch currents and the total current gives us 6 amperes. For the second challenge, determining total resistance allows us to find the total current and the specific voltage across the bulb, which is 4 volts. Here's a glossary of key vocabulary. Ensure you are familiar with these terms and their correct units, as using them precisely in your exam answers is vital for securing full marks. Make sure you can sketch these circuit diagrams from memory. A clear, well-labeled diagram is a powerful tool in an exam, often earning you marks even if your written explanation has minor gaps. Use this checklist to track your progress. Each point represents a core concept you should be confident in. If any of these feel tricky, revisit that section of the video before your exam. You've worked hard, and you're prepared. Remember, series circuits share voltage, while parallel circuits maintain it. Keep practicing these core rules, and you will be ready to handle any circuits question with ease. Good luck with your studies!